Okay, so we're going to use the Keq expression and the situation. So we're going to have an equation here, an equilibrium equation, and we're going to be able to A, calculate the Keq, and B, we're going to solve for a concentration of one of the substances. So we can find the Keq, that's one of the things we're going to be asked to do, and then we can solve for a concentration at equilibrium. That's the second thing we're going to do. Okay. All right, so you started jotting down some of these notes already. Here are the steps for finding Keq. It's really, really easy. And here's step one. Write the Keq expression. So we did that just before this, right? We just got finished doing something like that here. When you have an equilibrium equation, you always put the products on the top with the coefficients as exponents and the reactants on the bottom, coefficients as exponents. So you do that first. And then you fill in the values in the Keq expression with concentrations that are given in the problem. And sometimes, most of the times, they'll be given to you as concentrations. Sometimes it'll be maybe, well, the concentrations have to be moles per liter. They might give you grams per liter or something like that, which you'd have to then change to moles per liter. So I should write that in here too. Must be moles per liter concentration. All right. And the reason why that is because the coefficients here in the equation that we are using also in our Keq is a molar ratio. So you can't just use grams. That doesn't work. Because the ratio between the grams of each of these is not the same as the moles. So we have to keep that consistent. All right. And then B here, solving for a concentration, pretty much the same. Write the Keq expression, and then fill in the Keq value, and then isolate for whichever concentration you're missing. Okay? So it's using the Keq expression. And I've got an example below here that we're going to work through. Okay? So here's a reaction. You want to write down this reaction if you haven't yet. The reaction between gaseous sulfur dioxide, so that's reactant A here, and oxygen. Remember, oxygen is a diatomic molecule, so it's always O2 when it's by itself, is a key step in the industrial synthesis of sulfuric acid. Okay? Okay, so here we go. We have our equation, 2SO2 plus O2 in equilibrium with 2SO3 gas. Okay, all gases. So this is at equilibrium, very important. So a mixture of SO2 and O2 was maintained at a certain temperature, and remember the questions will have a certain temperature. You don't have to include that in any of your numerical calculations. It's just saying that these concentrations are true at this temperature, but they're not true at other temperatures necessarily. Okay, the equilibrium mixture contained. So again, this is at equilibrium. Very, very important. At. Not initially, but at equilibrium. Okay. So calculate the Keq. So that's our question. All right. So what you do is you write the Keq expression first. Very easy. The substance that we have on the product side are what? Which is the product side here? The right or the left? The right side. Okay. We only have one thing over there. No problem. We just put the concentration of SO3 with the concentration square brackets there, and then the coefficient is the exponent. Okay? So that's always the rule with the Keq. Just use the balanced equation coefficients as the exponents. Divided by the concentration of the reactants. That's going to be SO2. Concentration of SO2 squared. And don't add them here, always multiply O2 to the power of just 1, because there's a 1 for a coefficient there. Okay? So I guess to back up, we should make sure this is balanced, and of course this is balanced. So if it's not balanced, you're going to have to balance it, because you need to know what the exponents are. Okay? So Keq expression, go back to your little list there, write the Keq expression, there we go, we did that. So now we need to fill in the values of the concentrations that were given, and this couldn't be easier. We've got SO3 right here, O2, and SO2. So you just put the right numbers in the right spots, and then you just evaluate. So it's really easy. So let's just finish this up here. So the Keq then is going to be equal to, where's SO3? Right here. Okay. So that is 5.0 times 10 to the negative 2. You can write that in decimal form if you want. Squared divided by concentration of SO2 is 3.0 times 10 to the negative 3 molar. And that's going to be squared. And then times concentration of O2. And that's just going to be to the power of 1. Okay, so since it's Western Day, if anyone else got this number, give me a big yeehaw. That was lame-ha. Lame-ha. Okay, give me a big yeehaw if you got the same answer for the KQ. Ready? 1, 2, 3. Okay, so now I feel like you all just said yeehaw, not only the ones that got this number. Did everyone just say yeehaw there just for fun? Okay. Okay, so this is the right answer? Okay. Sometimes I don't like using this calculator. Okay, 79365. Fine. 79365. We'll round to the nearest whole number there. So, guys, this is a very large KEQ. What does this tell us about the system at equilibrium?
The products are favored.
Products are favored. What does that mean?
More products.
You don't know? You should know! There's more products than reactants. Where? When? Thank you. At equilibrium. So look at this. Okay. All right. Bring it back down here. So remember, this is a very important reaction or step in the synthesis of sulfuric acid. So it's in industry. So we want a lot of product to be formed here. This is what we're going for. We don't want a lot of unreacted reactants, right? So this is good. We have a very large KQ. That means there's virtually none of this left.
Wow.
Okay? All right? We good to go? Okay. Did you guys know, just another aside here, that did you know that water has an auto dissociation as well? Like it actually is in equilibrium with the H plus ions and the OH ions. So it actually dissociates. It breaks down a little bit too, but not much at all. So it's mostly water, but we still have just a little bit of this. And maybe you can search for the KEQ of water, see what that's like, if there is such a thing. That we're going to talk about that later in the semester, but you can look for that. But anyways, it does the same sort of thing. Yes?
Is there a way for it to be like neither?
All right, so we have another question here that's going to help. We're going to be able to exercise part B here, solving for concentration. Mackenzie? This should be baby stuff for you guys, okay? This is like baby algebra stuff, okay? Yeah, baby stuff. So I want you to do this right here. Write the KQ, which you already have done in part A. Fill in the values. So now you have the KQ. You have the concentrations for each of the reactants. I want you to find what the concentration of SO3 would be at equilibrium, okay? So I'll give you a minute to do that. And we'll see if you got it right. All right, so here's your answer here, your solution right here. So you should have your Keq expression, right? We don't know SO3, so that's don't know the concentration of SO3. That's your X. The X is squared though, so you have to remember that. Fill in all the other values. This is the same value here and here, so it turns out to be cubed, squared times to the power 1. And so here's your answer, okay? Make sure you use your square brackets, meaning concentration. And make sure you have your units there, moles per liter. And go to, something like this, go to 4 decimal places is always safe. All right, so that's the second part that you have to do. And this is just an initial using KEQ expressions to find KEQ and to solve for an unknown concentration. We're going to do a second part. We're going to bump it up just a little bit in tomorrow's lesson, and we're going to do the more complicated ones tomorrow. So make sure you show up for that tomorrow, because it's going to be exciting. You're going to miss out on something pretty awesome if you don't come. Okay, so I'll give you your assignment for today is finish 10 if you haven't. You should have, but you haven't. then finish it, and do 11 and 12, okay? So number 10, number 11, and number 12. So you won't be able to do probably after that until I show you. Well, some of you will be able to, but so your assignment really is 10 to 12 on our textbook page 562 and 3.